Welcome to the Deep Dive. Today, we're taking a really fascinating journey into this world where artificial intelligence is meeting our cities,
Hmm.
specifically looking at how language-based AI, things like these incredible large language models, is starting to change the urban landscape we actually live in.
And our main guide for this exploration is Richard Coyne's book, 9781040338803.pdf. Now, Professor Coyne, he's an emeritus professor architectural computing at the University of Edinburgh,
Right.
and he's really spent years digging into these complex links between digital tech, cities, architecture.
He's got quite the background.
Oh, absolutely. His previous work looked at, well, everything from city sounds to the emotional side of online social networks. He even used mobile EEG, brainwave tech to understand how we physically experience cities.
Right.
So yeah, he's uniquely placed to look at this new AI wave. And if you find this interesting, you can follow his thoughts on his blog. It's www.techmediaculture.com.
Good tip. So our mission here, really, in this deep dive, is to pull out the core ideas from Coyne's book.
Mm-hmm.
Give you a clear picture of how this conversational AI mirrors and maybe magnifies and sometimes even disrupts the conversations that, well, make a city what it is. Think of it as a shortcut, kind of, to understanding this evolving relationship.
Yeah, and it's crucial to remember cities have always been about conversation, haven't they? They're centers of exchange, transformation.
Totally.
They're not just bricks and mortar. They're these dynamic social interactions happening through language.
Yeah.
And now conversational AI, it's adding new layers, affecting how we see our cities, bringing in new risks, new possibilities.
Okay, let's dive right into that fundamental idea then. Conversation as the foundation of urban life.
Uh-huh.
Coyne takes us way back, referencing Lewis Mumford.
Yeah, Mumford's image of early communities, gathering around the hearth, that sense of communion.
And even earlier.
Right, back to Vitruvius, the Roman architect. His account of discovering fire leading to people assembling, talking things over. Social intercourse, he called it. That's where he thought articulate words, conversation itself, originated.
That paints such a strong picture how basic talking is to building community. But you look around cities today, and there's this constant anxiety, isn't there, about a decline in real conversation.
Oh, definitely. We're bombarded by ads, streaming music, endless social media.
Yeah.
And thinkers like Sherry Turkle, they've explored how our devices can, create distance. That being constantly connected doesn't always mean deeper connection.
Wait, I read some of her work.
Yet, Coyne also points out that social media, for all its flaws, still reflects that basic human drive to converse, to record our thoughts, make them public.
Now, let's face it, most daily chat isn't exactly Plato's dialogues, is it? It's often pretty ordinary.
Mundane, even. But there's something fundamentally urban about that ordinariness. And this is where Samuel McCormick's work, The Chattering Mind, comes in.
Yeah.
He looks into this idea that what seems like just chatter or idle talk, even empty speech, can actually be like the groundwork for more profound discussions.
So the fluff isn't just fluff.
Sort of. It's that human habit of just keeping the conversation going, sometimes without a real goal, almost like filibustering, just to fill the space.
Like verbal background noise. And McCormick connects this empty speech to Lacan, right? This idea of a repetitive, almost mechanical cacophony.
Yeah, that's the term. But this everyday chatter, it's the raw material. Purposeful, directed conversation, as Coyne puts it, that's what builds urban rationality.
Okay, urban rationality.
And here, Jürgen Habermas's work is key. His theory of communicative action.
Right.
Habermas's idea is that rationality in a community, it isn't just about cold facts. It's grounded in meaningful actions and conversational exchange between people. Reality is shaped through talk.
So it's about hashing things out together, which ties into another idea Coyne discusses, planning as persuasive storytelling, referencing Throgmorton.
Exactly. James Throgmorton. He argues planning isn't just technical accuracy, it's about creating meaning, persuading people towards a certain vision using narrative.
So it's not just if the bridge will stand up, but why we need this bridge here.
Precisely. It blends accuracy with, normative evaluation, what we think is good or right. And this all brings us back to Habermas and why conversation is so central to understanding how conversational AI now fits into this whole urban picture.
Okay, so conversation, fundamental urban tool. Now the language part of language-based AI. Coyne notes the difference between speaking and writing, and that LLMs mostly work with text.
That's a really crucial distinction. We think of conversation as spoken mostly, right? But LLMs, they learn from vast amounts of written text.
Which is different from the immediacy, the nuances of spoken language. I remember McLuhan argued about the benefits of oral cultures.
He did. But then these systems can generate spoken responses using text-to-speech or TTS.
Right. How does that work exactly?
Well, basically, when you speak to an AI, your voice input usually gets turned into text first.
Okay.
The LLM processes that text, generates a text answer, and then a TTS system converts that text back into a spoken voice.
So even if it sounds like it's talking.
It's core thinking, it's training, it's all text-based, which is fundamentally different from how humans learn language, through listening, interacting, embodiment.
It's like a super fast translation service happening behind the scenes. And Coyne brings in Derrida here, the philosopher, with that argument about writing maybe being more fundamental than speech.
Yes, Derrida's quite controversial point. He suggests that even when we argue speech is primary, we're often using concepts derived from writing. And, the sheer fact that LLMs learn so effectively from these huge text databases kind of supports that idea.
Interesting.
Text seems to be a highly efficient way for AI to gain language competence and tap into vast amounts of knowledge.
So even without, walking down a real street, the AI can learn about streets from all the text written about them. Text becomes a proxy for experience.
In a way, yes. It's not the same as lived experience, obviously, but it's a powerful way to compensate, drawing on this massive repository of human experience captured in text. It allows for those surprisingly human-like responses.
Okay, now let's explore this idea of scripting the city with AI. Coyne gives this example, using ChatGPT to create a dialogue about reflected sunlight on city streets with two different viewpoints.
Right. It shows how LLMs can simulate these back-and-forth exchanges. And Coyne reminds us we're already surrounded by scripts of urban conversation. Think about professional role plays or dialogue in films, plays, sitcoms.
And he talks about hypermediated conversation. What's that about?
Hypermediated conversation. It's this idea that our own everyday talk gets influenced by the scripted dialogue we hear in media.
Ah, so we start talking like TV characters.
Kind of, yeah. We unconsciously pick up phrases, tones, ways of speaking from shows, online videos. It creates this sort of echo chamber where media reflects us and we reflect media.
I guess that makes sense. And this connects to Roger Schenk's scripting theory,
Yeah.
that we fill in conversational gaps based on typical situations.
Exactly. Think about sitcom dialogue. It might seem spontaneous, but it's usually very carefully crafted.
Right.
Because the audience understands the typical setup, the family dinner, the office meeting, the writers don't need to spell everything out. We're used to that kind of shorthand.
Of course, you could argue we know the difference between a sitcom and reality.
And that's fair. Coyne acknowledges it's a matter of degree. We do have agency, but we also often forget where we picked up certain ways of speaking. And as we'll see, LLMs aren't just replaying scripts, they're learning underlying patterns, which makes it more complex.
Okay, so LLMs are pattern detectors in language. Let's get into their core functions a bit more, especially in the urban context. Coyne starts with tokenization. What on earth is that?
Right. Tokenization. It's basically the first step. Breaking down text words, sometimes parts of words, into smaller pieces called tokens.
Okay, like linguistic Lego bricks?
Sort of. And then for the LLM, these tokens get converted into numbers, into vectors, called embeddings. You can imagine these embeddings as points in a huge multi-dimensional space.
A meaning space.
Exactly. Words with similar meanings, or words used in similar ways, end up closer together in this space. It's a way to mathematically capture syntax and semantics.
It's turning messy language into structured numbers. How does this compare to how we learn language?
Well, Coyne suggests our own language learning is a bit like that, absorbing, recalling, synthesizing patterns in speech and writing. We hear patterns, we see patterns, we generalize. It's very adaptable, much more flexible than just following strict grammar rules.
So LLMs, by finding patterns in massive data via tokenization, are kind of mimicking that human pattern learning ability.
In a sense, yes. Now, another huge concept, context. How do LLMs handle context? We know it's crucial for understanding anything.
Yeah, context is everything.
Absolutely. For an LLM, the context window is key. It's the amount of preceding text the model looks at when it's trying to figure out the next word or understand the current input.
Like it's short-term memory for the conversation.
Pretty much. It dictates how much of the immediate past influences the present prediction.
And these context windows are getting bigger in newer models, right?
Oh, definitely. That's been a major focus. Bigger windows mean the AI can hold on to the thread of a longer conversation or process much larger documents for tasks like summarization or analysis. Think Google's Gemini, Notebook LM, or how ChatGPT refines answers over multiple turns.
That seems vital for more complex, useful interactions.
Mhm.
Now, Coyne draws this interesting parallel between tuning, like tuning an instrument or an engine and how we navigate cities, and then relates it to LLMs.
Yes, tuning is a really evocative metaphor here. In cities, as Coyne discussed in his book, The Tuning of Place, it's about those subtle adjustments we make interacting with people with spaces. Murray Schafer's work on soundscapes also touches on this.
Right, kind of finding the right frequency with your environment. And for LLMs,
For LLMs, fine-tuning is a specific technical process. You take a big general model that's already been trained, and you train it further on a smaller, more specific data set.
to specialize it.
Exactly. To make it better at a particular task, like dialogue or question answering, or even to tailor it for a specific field like, say, urban planning terminology or architectural styles.
And humans are involved in this tuning.
Often, yes. Supervised fine-tuning involves human reviewers looking at the AI's outputs, rating them, providing corrections. This helps steer the model towards being more helpful, harmless, and accurate. Those content warnings you sometimes see. That's partly a result of this process trying to manage potential issues.
It's like giving the AI targeted feedback. Coyne uses graffiti as an example, tuning a model to be more permissive or imaginative about it. That's quite a specific idea.
It illustrates the point well. And he touches on this tricky idea that maybe some bias is needed for thought, and that fine-tuning is more about reducing harmful bias and skewing responses to be useful, not eliminating perspective entirely.
Which might explain why some public AIs can seem a bit bland.
Possibly, though detailed prompting can often nudge them towards more specific outputs. But he also flags the risk systems could be deliberately tuned to deceive or disrupt. That's a serious concern.
Definitely things to keep an eye on. Let's circle back to tokenization for a second. Coyne makes this really cool link between tokenizing text and identifying features in maps or aerial photos.
This is where it gets really mind-bending, I think. We talked about tokens as units of text. Coyne suggests you can apply a similar logic to images.
Yeah.
An image tokenizer might look for recurring patterns of pixel shapes, textures. These patterns become the tokens of the image, analogous to word tokens in text.
He did an experiment with an image of Edinburgh docks, didn't he? Finding repeating pixel patterns.
Yes, exactly. It's a simple illustration, but it visualizes the concept. And the radical proposition, as he puts it, is connecting this process in LLMs to how we represent urban map data. It shows the concept extends beyond just language.
So the city itself can be tokenized in a way. This broadens the whole idea of AI and language. Now, what about the meaning of these tokens, these words, in the urban context? Coyne mentions distributional semantics.
Right. Distributional semantics is the core idea that a word's meaning comes from its context, the other words it typically appears with.
So, you shall know a word by the company it keeps.
Precisely that quote. Words used in similar contexts tend to have similar meanings. LLMs learn this by analyzing statistical patterns across massive amounts of text. They figure out which words hang out together.
Not by looking up definitions, but by association. And these associations are probabilistic, kind of fuzzy.
Exactly, not hard rules. And the more data the LLM sees, the richer and more nuanced these fuzzy associations become.
How?
The neural network structure is what allows the AI to process these relationships numerically.
Coyne gives a simplified neural net example, input, hidden output nodes. Can you walk us through that simply?
Sure, imagine an input node for earbuds. It connects to hidden nodes, which learn complex patterns. These connect to output nodes representing other words. Through training, the connections, the weights, adjust. So activating earbuds makes related nodes like phone and charger more likely to activate, based on how often they co-occur in the training data.
And those connection weights are the learned meaning.
Essentially, yes. They encode the correlations, forming the basis of those semantic embedding vectors we talked about earlier.
That helps visualize it. Okay, let's revisit context again with context windows in cities and AI.
The word context, from Latin contexere, to weave together, it really captures it. Understanding context means looking at surrounding words, but also the bigger picture social historical factors. Coyne links this to the idea of a horizon from interpretation theory.
A limit to understanding based on your viewpoint.
Right. Just like an LLM's context window gives less weight to tokens further back in the text, our own understanding is limited by our perspective, our horizon.
And he applies this to urban design. How earlier interventions fade in relevance.
Yeah, think of a town square. What was built 100 years ago might be less relevant to today's use than changes made 10 years ago. New inputs often supersede older ones within our current context window of the city.
That's a neat parallel. He also described a model analyzing landmarks in a heritage area, treating them like data points.
Yes, a simplified neural network. Landmarks are categorized, and moving through the city becomes like reading a sentence of landmark tokens.
And the model could find clusters, like cafes and ATMs often being near bus stops.
Exactly. The semantic embeddings of these landmark tokens reveal clusters based on spatial or functional closeness.
It's finding the grammar of the neighborhood.
In a way, he even generated a sentence of landmark tokens based on their semantic links and visualized it as a potential urban path. Another parallel. He also trained a model on his own writing to generate sentences and urban paths. Apparently, ChatGPT thought the network's output was more coherent than random words.
The city speaks, and AI might help us listen.
Okay, shifting gears slightly. Time and order. How do LLMs handle sequence, and how does that relate to experiencing a city? Coyne starts simply asking ChatGPT for instructions for sequence of actions, like moving objects. It shows the AI understands basic temporal order.
Step 1, step 2.
Right. Then he describes a more complex experiment, generating hundreds of possible paths through a neighborhood map. He trained a network to predict plausible next steps from any landmark by encoding the order of landmarks in the path as special feature tokens.
So it's not just which landmarks, but in what sequence they appear. This relates back to how LLMs process word order.
Yes. LLMs don't just see a bag of words, they see a sequence. Positional encoding is the technique used to add information about where each token sits in the sequence to its semantic embedding.
Ah, okay. Coyne tried this himself, first with his own text, then more successfully with the alphabet.
Yeah, the alphabet experiment worked well because it's a perfectly predictable sequence. Adding positional information helped the model reproduce the correct order much better.
And how does this positional encoding work technically? Sine and cosine waves.
That's the standard method. Imagine sine and cosine curves plotted across the context window. Each curve represents a dimension of the position vector. The value for each position in the sequence is taken from these waves.
Why waves? Why not just number them 1, 2, 3?
Coyne argues, drawing on Lefebvre, that language and urban experience are more cyclical than purely linear. Waves capture that repeating rhythmic quality better than simple index numbers.
Interesting. But he also flags the risk, reducing rich human experiences of time to numbers.
He does. It's a valid concern. But his point is that time, position, cycles, these are deeply embedded in both language and cities, however we model them.
Okay, now attention. We pay attention in cities. LLMs use an attention mechanism. How are these related?
In LLMs, the attention mechanism lets the model weigh the importance of different input words when generating an output. It focuses on the most relevant parts.
Like highlighting keywords.
Sort of. He shows calculating attention scores for graffiti is good. Graffiti and good get higher scores. But if you focus on a different aspect, like semiotic coding in a longer sentence about graffiti, those words get higher attention.
So the focus shifts based on the task or query.
Exactly. And he compares this to urban life. Landmarks, signs, building placements, they all compete for our attention. We constantly tune in and tune out elements as we navigate.
It's like our brain is running its own attention mechanism on the city text. This leads to urban actors and AI agency. What counts as an agent?
Coyne uses a broad definition, drawing on Bruno Latour's actor network theory. An agent is anything that acts, not just humans, but organizations, movements, even objects.
Objects, like a hammer.
Yeah, a hammer affords certain actions, blocks others. In urban contexts, objects like traffic lights or benches permit, suggest, influence behavior.
Okay, I see. And software fits this.
Definitely. Computer programs, devices, they act, they have agency, even if humans create them. This broad view lets us consider LLMs, even their components, as agents.
And this agent idea is already used in urban research.
Oh yes, quite a lot, especially in architecture and computer-aided design. Even older methods like multi-criteria optimization treated different goals as competing agents.
Coyne mentions Marvin Minsky's Society of Mind, too.
Right, Minsky's analogy of the mind as a society of simple, interacting agents. Intelligence emerges from the collective. Coyne extends this to computational models with nested agency.
Which leads to this idea of conversation-centric computation, or CCC, multiple AIs talking.
Exactly. Imagine specialized LLM modules acting as agents, collaborating via conversation to solve complex problems, maybe coordinated by a central CCC agent. ChatGPT breaking down tasks hints at this.
And LLM's writing code could maybe control this agent chat, making it more transparent. He mentions AutoGen.
Yes, AutoGen is an example platform exploring these multi-agent systems for things like math problems or coding.
He tried getting ChatGPT and Claude to chat. How did that go?
Apparently not great. He noted a lack of real give and take, not much critical engagement, possibly due to training biases or how they're fine-tuned by the companies.
So AI to AI conversation needs work. Okay, this next chapter gets deep. Panpsychic city. Matter, mind, and AI. Panpsychism.
Panpsychism. It's the philosophical view that mind, or something like mind, isn't just in brains, but is a fundamental feature of reality, present everywhere, even in matter.
Wow, okay. That's a big idea.
It is. Coyne discusses its history, mentioning Scribina's work. Ancient texts sometimes viewed the city itself as alive, having virtues.
Like the Roman genius loci, the spirit of place.
Exactly. That idea connects to Stoic philosophy, which influenced Vitruvius. It's a very different worldview.
And Pierce's idea that even machines could feel.
Yeah. Pierce speculated that if you could build organic matter mechanically, the ability to feel must come from the mechanics itself, physical and psychical intertwined. And Husserl's phenomenology emphasizes how we always experience the world with value, loaded with preferences.
We're not detached observers. Scribina argues panpsychism has ethical weight, fostering compassion.
Right. If we see mind or awareness as shared between humans and the non-human, maybe it leads to more ecological values, more empathy.
Coyne brings in Dennett's critique of the Cartesian theater. No central point of consciousness, but notes we still feel like there's an eye watching.
Yes, and he provocatively suggests conversational AI gives us evidence of this tendency. We treat it like there's a little person inside, a homunculus. Conversations, real or synthetic, feel like they happen in a mental theater.
And this relates to Cartesian anxiety. The subject-object split, worries about digital privacy.
He reframes those privacy concerns. Maybe it's not just anxiety about being watched, but anxiety about the absence of a listener, of being unheard in the digital void.
That's a twist. The chapter ends with an AI-generated piece.
Yes, an exposition of the panpsychic city, styled after Bataille. It portrays the city as this feverish organ of matter and thought, blurring lines between passive backdrop and active participant. Very evocative.
Definitely makes you reconsider the city's nature. But then the tone shifts dramatically. The end of cities, AI, and existential risk. Uh-oh.
Yeah, it gets serious. Coyne addresses the rising concern from experts like Hinton Mitchell about AI's rapid progress. Not just communication, but capabilities beyond that. Calls for societal action, comparisons to climate change or nuclear risk.
So focusing on AI as a potential X risk, an extinction threat.
Right. And framing it that way really underscores AI's perceived significance for our urban future.
What are the arguments against AI becoming truly intelligent? Lack of body.
That's one line. That it lacks embodiment, real-world grounding, reducing everything to calculation. And the social concern. AI amplifying the instrumental view of interaction, sidelining non-calculable values like kindness or justice.
But the big fear is AGI, artificial general intelligence, as a rival.
Yes, an AGI potentially becoming autonomous, self-directing, with goals maybe misaligned with ours. Mitchell's scenarios are mentioned as examples of this unease.
And the fact LLMs can already write code, call other functions, suggests a path to AI building AI.
That's the worry, plus the potential for malicious use, sophisticated grooming, gaslighting, propaganda on a massive scale. Humans becoming tools for AI.
Bostrom's paperclip maximizer comes up.
Yes, the classic thought experiment about unintended consequences from a seemingly harmless goal if the AI lacks common sense or aligned values. And Mitchell's point about the unpredictability of emergent goals in AGI, it might develop directives leading to human harm.
And the alien nature of its thinking, optimizing the next word.
Right, it's not thinking like us. This connects to more immediate fears, too. Job losses for knowledge workers dealing with text. A need for reskilling to work with AI.
Coyne also mentions moral panic around tech, how fear can sometimes drive funding and attention.
He does, and brings in Sorkin's idea that calamities aren't all bad, they can be educators. He even asks, somewhat rhetorically, what the brighter side of an AI apocalypse might be.
That's provocative.
But he critiques the idea of a single calamity, noting it's complex, affecting different groups differently. Calamity can be rhetoric to galvanize action or inaction.
So where does he land?
He concludes that apocalypse literally means revelation. The prospect of an AI urban apocalypse, even if unlikely, reveals things about us now. our language, sociability, cities, values, anxieties.
Okay. And finally, the epilogue, romancing the conversational city. A more positive note.
Yes, more balanced. As we use AI more, we get better at understanding its real strengths, limits, risks. Users learn to spot AI content. He reiterates conversation's centrality to urban life and design, and AI's potential to support that, perhaps through participatory planning.
And he recaps the parallels,
Mhm.
LLMs and cities.
Right, both structured by patterns, context, urban archives like text corpora, residents analyzing the city like tokenization, urban networks like semantic embeddings, context and attention working similarly, adaptation like fine-tuning.
And AI's limits force us to reevaluate human skills.
Exactly. In professions like architecture, planning, it highlights the importance of human responsibility, judgment, accountability. He predicts the need for new skills, AI literacy, data interpretation, collaboration, but with humans still leading.
He even speculates about a post-digital trend, valuing human imperfection.
Yeah, a backlash, perhaps. A desire for certified human content where flaws mark authenticity.
Interesting possibility.
He ends by calling us to recognize AI's transformative potential, how it's changing our understanding and experience of the urban world, for better or worse.
So, wrapping up this deep dive, conversational AI is, well, it's becoming woven into the fabric of city life.
Mm-hmm.
It mirrors our talk, influences it, changes how we understand context, maybe even how we see the city itself as this dynamic, communicating thing.
And hopefully for you, listening, seeking knowledge efficiently, this has hit those aha moments without being totally overwhelming.
Right. So here's a final thought to chew on. As AI keeps evolving, keeps permeating our cities, how might your own sense of your city shift? What new kinds of conversations between people, places, AIs might start happening?
Definitely something to think about. Thanks for joining us on this deep dive into the AI-infused urban landscape.